The deuce. Number 2 from this section, finding out about definite integrals. Now, here's going to be one of the games that we ask you to play. We're gonna find the answers to an integral without using any integration techniques, just by using a little bit of common sense, a little bit of logic, using some shit that we know already. Using area formulas. There you go. So there's all the shit we did before. Oh gosh, look at all those definitions and theorems and words and symbols and all kinds of good stuff. But here we go. That's where we want to be. We want to use area formulas to calculate the definite integrals. So there we have it. We're from 0 to 1 of the square root of 1 minus x squared dx. All right. And then we have the integral from 0 to 3 of just x minus 1. So let's go look at number 1. Look at our first one. So we're going from, ooh, Jesus. We're going from 0 to 1. And what is it again? It's the square. Oh, that's what I need to look at. It's the square root of 1 minus x squared dx. And I'm saying you can just go solve this thing just by drawing a picture. You'll know how to solve it. You'll know what's up. So let's look. Let's start breaking this thing down into pieces where we're going to say, well, our x value is between 0 and 1. And that comes from right here. So we're only going to look at x values between 0 and 1. And that our f of x, well, that's equal to the square root of 1 minus x squared. And we want to find the area under that curve from 0 to 1. Values of x from 0 to 1. I think it might be easier for us to maybe call it y. Because is everybody just going like, oh yeah, square root of 1 minus x squared? Clearly, I know exactly what that is. Everybody feeling that way? You're like, yeah, I got this? Well, I would hope you would, too, because it's actually, this is just the upper half of a circle. So let's just play a quick game. If we were to square both sides, we would end up that y squared is equal to 1 minus x squared. And if we were to move this over the other side, you get x squared plus y squared is equal to 1. Anybody ever seen x squared plus y squared equals 1? Hell yeah, you have. It's called the unit circle. That's the frickin' unit circle. So, well, let's do one of these. And we're like, well, let's make a frickin' circle, huh? Let's do this. I'm going to cheat because I got this little technology thing. I'll make myself a circle-ish. Is that a circle? Nah, let's go with that. Put it right in there. Boom, circle. We nailed it. Good job, us. Of course, I don't have it like scaled up right or anything like that. But we'll say it's from 1 to -1. Oh, but wait a second. We're only looking from 0 to 1. We don't need this whole thing. And from back here, we squared both sides of this sucker, huh? That y has to be positive, so we couldn't actually take any of this. The only shit we need, this is bad. We can't have any of this. No negative y values. And it says that our x is only from 0 to 1, so it can't be this stuff. The only thing we're looking for is the area right inside here. We're looking for a quarter of that frickin' circle. Not the whole damn thing. We want 1/4 of a circle that has a radius of 1. 1/4 of a circle that has a radius of 1. And we know the area of a circle. Well, none of us would be in calculus not knowing the area of an effing circle. Right? Well, we draw it again. And basically all we have going on here is this. Right? From x is equal to 0 up to x is equal to 1. And we're going to find this area right inside of here. So, as I said, to solve this thing, we're going to say that this is equal to 1/4 the area, which is pi r squared. But in our case here, our radius is equal to 1. Hence the answer is 1/4 pi times 1 squared, or pi over 4. And there's our solution. So here's the game that you're going to be playing with these, is you need to look at your function, whatever it may be, and you're going to need to set it up. Set it equal to y or something. Figure out how it's graphed. Punch it into Desmos. But don't use Desmos too much, all right? You still need to know how to graph shit. We will come back. We will be back on campus one day. Well, not if my bosses have anything to do with it. They like this shit. They love it. More money to be made. But I didn't say that. Okay, moving forward. So we want to be able to graph our functions that are in yellow. And then we just have to look at our bounds, our x values, and find out what the area under those curves might be. All right, number 2. What was number 2? What was number 2? Come on. Oh, from 0 to 3 of x minus 1. 0 to 3 of x minus 1 dx. So let's write it down first. Let's get our x values. Let's take a look. We're like, okay, so we're only looking at x values in between 0 and 3, right? In between 0 and 3. Cool. So we know where our x values, so we can find that area. And then we have our function. That function is equal to x minus 1. But again, it's a lot nicer if you just write it as x minus 1. Y is equal to x minus 1. Because now, shit, we're just back in algebra, asking you to graph a line. And I'm pretty sure we can do it. Everybody know what the x-intercept is? I think you can find that. Or shit, not the x-intercept, the y-intercept. Isn't that down here at -1? The x-intercept's at 1. It's got a slope of, let me think. What sort of slope do you think this thing might have? I won't this move. Please move. Nope. Okay. I will not use a ruler. I will just draw it. So there's our line. Y is equal to x minus 1. And of course, this goes up to 2 and to 3. So let's kind of break it off and go, well, wait. We're stuck in between. We want to find the area from 0 up to 3. So we have our negative area down here. And then we have some positive area. Oops. We have some positive area up here. So let's call one of them, let's call this down here. Let's call this one A1. And we'll call this one up here A2. And our answer, our total area, will equal our A1 plus our A2. So, oh my gosh, we have to find the area of triangles. Oh, I thought it was just rectangles, but now all of a sudden we're messing around with triangles, so let's go find it. Now, if we look at our first one, our A1, our base is 1, but our height is -1. So we'll do base times height plus base times height, but of course I'll go 2, 2, 1, 1, because they're going to differ. So our base is equal to 1 on our first one. All right, from 0 to 1 is 1. But the height, here's the frickin' weird, -1. The height's -1. Look, right down here, -1. Now we need to go find the area of our, oh shit, that's not the formula for triangles. That's the formula for rectangles. It's 1/2 base times height. I'm sorry, I screwed up. Now we got to do 1/2 our next bases. So how far is it? I wonder how far it is from 1 to 3 to find that base. No shit, it's 2, huh? No shit. Now what's going to be the height over here? Uh-oh. Anybody know what this height's going to be? Right in here? With this slope of 1? I'm pretty sure it's 2. I'll let you do the math on that. So we go through and we solve and we get -1/2. Right? Because -1 times 1/2 is -1/2. The 2's cancel out over here, just giving you 2. And it looks like we have an answer of 3/2. So there it is, our integral. Right up here is equal to 3/2. That is the area underneath our curve. Hooray! Using area formulas to find the areas. Not approximate, but to actually find the exact areas. Now, we don't want to do that stuff all the time. We would much rather be able to go into a problem like this, evaluate x minus 1 dx, do little games like this, and evaluate from 0 to 3. We'll talk about that shit later. See you soon.